Hey, welcome back to ZK Master Tech. If it's your first time joining us, my name is Zeth. It's not Zach or Jeff or I don't know. People call me a bunch of different names in the comments below, but my name is Zeth with a Z. It's kind of like Seth, but it's got a Z. Anywho, glad I cleared that up. Today we're going to be covering the path of the kernel. So anytime I get a new technician that I have to train on combines, the first thing that I do is I teach him the path of the kernel, and a bunch of you guys wanted me to cover this on video, so I'm going to go over that today, and we'll do that. And then if you stick around towards the end, I'm going to show you a cool new tool that I bought, and you guys are going to dig it because it kind of blew me away. So let's get into it. All right, so it all starts here with the header, and this is a John Deere 12-row chopping corn head and folding. See these cylinders up here? It will fold up for transport. Anywho, so the corn plant, the stalk, hits right here, okay? And then you got these stalk rolls down here, and these are spinning opposite of each other, and what it does is whenever the stalk comes into here, it chews that stalk up and shoves it into the ground. It goes straight down, and then on a chopping corn head, you got blades in here that are spinning kind of like on a mower deck, and it chops that material up a little finer. And so right here you got deck plates, and what that's going to do is when the stalk gets shoved down, boom, it hits this corn cob right here. This corn cob can't make it through the deck plates, and that spacing is adjustable as well, and it pops the ear off, and then these gathering chains here take it all the way back into here into this auger, and then this auger is bringing in all the ears of corn into the feeder house, which is going to be in that opening right there. So that's how we take it from the plant, pop the ear off, goes back, augers it into the feeder house. All right, let's go back into the feeder house. All right, so here I got the feeder house. This is a John Deere S780 combine that I'm doing an inspection and repairs on, but I got all the shields off of it so we can kind of peek inside and I can show you the path of the kernel. So here, this feeder house is sitting inside of that corn head. The corn head is sitting right here, right on top of here. So our ears are getting augered in towards the center into the feeder house, and then here we have a conveyor chain that is spinning, and then these ears of corn are getting shoved down through here, back through the feeder house, goes clear back here, spits it out down here to where the feed accelerator here is spinning just like this. And what it's doing, it's kind of threshing and accelerating the crop flow into the rotor. And you can't see it on here, but there are great big flighting. It's kind of like a corkscrew on the rotor, which is threading into that crop flow, so it can start spinning around and threshing into that rotor. But down in here, there's a little kind of a pit down in there, and there's a drawer you can drop down, and that is our stone trap. So any really heavy objects like rocks and stones and hopefully field cultivator shanks, wink wink, will fall down into that stone trap area and not go into the feed accelerator and the rest of the threshing system. So it's one of those doors you want to drop right here. There's a little door right here which drops that door down to allow you to clean the rocks and stones and stuff out of there. So it's really important to keep that clean because you need an area for that stuff to go. If it's all full of junk, then the rocks will just go right into the machine. So our ears of corn are being accelerated into the rotor from the feed accelerator. All right, well, once we get past the rotor flighting, we're going to go into the threshing area. And right here where these grates are, these are our concaves. So our rotor is turning, and right here where these concaves are, you've got threshing elements in there. And what that's doing is grinding up these ears of corn and getting all the corn off the cob. And then this concave, you can see these adjustment rods, we can go up and down. We're increasing or decreasing the threshing clearance, which our threshing clearance is generally the width of our cob with no corn on it, because we don't want to crush the cob, we just want to get all the corn off of it. So the corn is dropping down through these grates like this into our shoe augers, or conveyor augers is another word for it. But these augers are turning, and then we're augering that corn back into here, on our, and we're dumping it right onto our screens, right onto our chaffer. All right, so it's going to go into the pre-cleaner first, and then it's going to drop down onto the chaffer screen, and then below that is the sieve screen. So the majority of our corn is getting threshed off the cob and falling down there on the shoe augers, but it's not going to get all of it off, right? So whatever's left is going to be separated back here, and on this section of the rotor is where our separator tines are and our separator crates. So up here, we're trying to get all the kernels off this cob to drop down somewhere in these first 3 grates, right? If we still got corn coming out of this grate here, it's going to hit this loss sensor, and it's going to tap on this pad, and the controller is going to monitor that and know that we have rotor loss. So whenever corn is coming out back here and hitting this pad, we're going to call that rotor loss, because we want all of our kernels of corn, ideally, to be dropping out before this point. And it's either going to fall down on this return pan, which is shaking back and forth, which it returns. Anything that falls on this pan is going to return back and drop down here onto the pre-cleaner of the chaffer. So our goal is to get everything to go here. So let's talk about this return pan a little bit. So this return pan goes from about the second separator grate and goes all the way back to the bottom of the discharge beater. So there's another discharge beater behind the rotor, which is taking the material, the residue from the rotor, and accelerating it and throwing it into the chopper. But it also threshes and has a little concave underneath it. And if there's any corn or any material left over that needs to be cleaned again, it's going to drop it down on this return pan and make its way towards this way, dump it back over the screens again. Or we could get recycled material from the tailings out of this auger right here. There's a tube and an auger, and that's going over to the rethresher, the tailings elevator, and bringing in recycled material back onto the return pan to get dumped back here. So this return pan is shaking back and forth, and that allows the material to come over here and get dumped into here. Okay, so we talked about how we get all the corn off the cob, or maybe we got soybeans and we're trying to get all the beans out of the pods, right? And that's all happening in the threshing and the separating right here in the rotor. So, but all that material, it's not actually pure corn. I mean, there's some residue in there, right? There's some, dust and leaves and pieces of stalk and, all kinds of different plant material that we don't want to end up in the grain tank in our final sample, right? So how do we do that? Well, we do that with the cleaning shoe. So in the cleaning shoe, we have a cleaning fan. So this fan is spinning and it's blowing air up like this. And in here on our shoe, we have 2 frames that sit inside the machine. The top frame is the chaffer frame. The bottom frame is the sieve frame. And in the chaffer frame, we have a chaffer element, which is the screen, which has adjustable louvers. And then in the sieve, we have the sieve element that has adjustable louvers. Well, we're blowing air up through those screens And these arms here are called the pitman arms, and they're on cams. There's a drive shaft that runs this, and there's arms like this on both sides. And when this drive shaft rotates, there's cams right here, and it makes these arms move back and forth really fast. And this arm here actually comes up and attaches to that return pan I was talking about. So when this is moving, these frames are sitting there going side to side, moving back and forth, really kind of at this angle right here. And then we're blowing air up through there. So when we're dropping a bunch of corn down on there, it's a dirty sample, but if you took a handful of corn and dust and dropped it right in front of a fan, the corn is heavy enough, it's going to fall down, but the lighter weight stuff, the residue, is going to blow up and out, right? So our mission is to get all the grain clean by using the fan and the screens, and we want it to come down right here. Right here is our clean grain auger. So this is the bearing and the speed sensor on the left-hand side of the machine. So there's an auger here, and it is going to be augering grain to the right side of the machine to the clean grain elevator to take it up into the grain tank. So our residue is continuing to go up and out, and eventually we want all the residue to go back here and go into our chopper. And we want all our grain to fall down here. Now, not all of it's going to fall down into the clean grain auger. Some of it's going to fall, back in here at the back end of the cleaning shoe, and that is going to fall into our tailings auger, and that's going to go into the tailings system to be recycled to come back through that auger tube I was showing you to get put back into the machine and get re-cleaned again. So we can give the opportunity to get every kernel or bean or whatever you're harvesting into the grain tank as possible. We don't want any corn going out this way, because if it goes here out this way, it's going to be going out the back and not into the grain tank, and that's not what we want. So I've got the chopper open so we can climb in the back and take a look at the cleaning shoe. Okay, let's get some light on the situation here. All right, here's our cleaning shoe. Now up here, see, this is the return pan I was talking about, this guy right here. There's that concave discharge beater grate, also called, that's underneath this discharge beater. So this is taking all the material that's coming out of the rotor and it's throwing it backwards to the chopper. So it'll also thresh right here and make the corn and stuff fall through this grate back onto the return pan, so it can be put in back up here. And you can see those 4 shoe augers right there. So that's going to be dropping all your grain onto that first green section there. That is our pre-cleaner. And then it's going to be coming back right at the front of the chaffer here. So this piece right here is our chaffer element. And these louvers are adjustable. So we can adjust the clearance in between right here, bigger or smaller, to kind of customize how well we clean our sample. And each crop is going to have a preset starting point of where you want to put your chaffer sieve, threshing clearance, cleaning fan speed, all that stuff. And that's another topic for another day. But what this is doing is we're blowing air up through these screens and dropping our threshed material onto here, and the lighter weight material is going to be blown back this way, and the screens is going to be sifting it. Basically kind of like sifting for gold, right? You're shaking it, cleaning it, trying to get all the good stuff, right? So underneath this chaffer, there is a sieve screen, which looks almost identical to this. And the chaffer is usually opened more than the sieve is. And this is a dual adjust chaffer. So you see we got these fins back here. I think there's 10 rows here. Well, these are closed a little bit too much. Level land, you want to open them 5 to 10 millimeters. What that's really doing is it's creating kind of an air choke. So we don't, if you have these open up too much, then you're not going to get the airflow up here where you really need to be doing your cleaning. So when we choke these down, it forces that air to be more kind of saturated in here where we want it, where we're dropping a bunch of material on. That's where we want it to be. So if material drops in over here at the front, it's going to go down to the clean grain auger. But if it drops back in here, then it's going to be going into the tailings auger to get recycled and be put back onto the return pan. All right, so here it's kind of hard to see, but you know, when all the material, you can see kind of the wear pattern of how it goes. The material is being shoved from the discharge beater, and then usually, you know, the chopper sits right here in this opening. So it's dumping it right down here, and then it's going into the chopper housing, which we have a giant rotor in there with a bunch of chopper hammers. And notice they've got fins on them. Well, that creates wind movement. So, and then we're chopping the material as well. So we're cutting the material down into a fine cut, and then we're blowing it out the back. So that's our mission, to get all the residue out there into the chopper to where we can chop it and spread it in the field as wide as possible. Also back here, see that little yellow thing down there? Well, that's a cleaning shoe loss monitor pad. And there's 2 of them back here. There's one here and there's one here. So when corn drops down in there and taps on this pad, like I said, that controller is monitoring that, and then it's going to know that we have shoe loss. We're going to call this shoe loss when we tap right here. And these fins are just to keep large material and cobs from dropping down onto those sensors to get a false reading. And then underneath this plate here, we have an actuator that is hooked into this chaffer, and it's just moving a plunger in and out, and that plunger is attached to a rod that's attached to all these louvers that allows that to move the louvers to increase or decrease the distance between the fins. And then this is a dual adjust chaffer, so we have a manual adjustment here, 10 millimeter hex, that we can adjust the clearance here for the back. And we're using this as an air choke. Then here, you'll notice there's giant air chutes on the side of the combine. And what those are there for is to kind of purge some of the air from the cleaning fan out. Because like I said, that chopper's got fins on those blades, and it's creating an air force, and we got opposing air forces hitting each other. Well, we need to dissipate some of that so we can keep everything moving this way. So that's what those housings are there for, to discharge some of that air out the sides, so the material is not fighting 2 different wind forces, and it can go out this direction. So now on this one, we have a power cast tailboard. So we got 2 hydraulic motors moving these spreader paddles, and it's taking the material that's being chopped by all these chopper hammers out this little discharge housing into these spreader paddles, and then we're spreading it, and we're trying to spread the material about the width of the header. We want a nice even flow across the ground. And we talked about how the material gets threshed and gets dropped down onto the screens, and then we're cleaning it using the screens, moving back and forth in the cleaning fan air, moving through it. So the heavy grain is falling down that has been cleaned, and our goal is to get it into this giant elevator right here. So in this elevator, we have there's our auger right there. So that's our clean grain auger, and it's bringing it into this paddle chain here. So we have a giant chain that's running in this elevator with paddles. And what that's doing is the corn's coming right here, and then this paddle's coming along like this, scooping it up and taking it up the back side of the elevator. So there's a divider in this elevator, and we're going to be scooping the grain up and taking it up to the top. Now what you see here is here we have our moisture sensor, and then we also have a grain quality camera. So it's bringing in a sample, we're measuring the moisture, and then we're also taking a picture of the sample. And the combine uses that picture to determine basically how clean the sample is. And it can detect a bunch of different things within the camera, and then it can make adjustments using interactive combine adjust to make, do we need to speed up the fan, slow the fan down, open up the chaffer, open up the sieve? Do we need to increase the rotor speed? Do we need to decrease the threshing clearance? It's going to make those decisions based on what it's seeing here in the camera and also in the loss monitor sensors. And there's a lot of other sensors that we're going to talk about later on, but that's what that guy is there. So our grain is going up and then going into the grain tank. Now here we have that tailings system I was talking about. And what makes this a Class 8 machine is we take that tailings and then we bring it up, same concept, paddle chain, bring it up into here, and then we dump it into a little mini rethresher. And it kind of looks like a mini feed accelerator or discharge beater. And it's kind of got a little adjusting concave here with rasp bars on it to rethresh that material. Because back in the older days, or a 6 or 7 class machine, this tailings elevator will come up this way, and it'll actually have a little auger, and we're going to dump it back into here to get rethreshed. Well, that takes up capacity of the machine, right? With an 8 or 9 or 10 or 11 class machine, we don't want recycled material going in and filling up space up there. We want more capacity. So we're going to rethresh it back here, and then it's going to dump it into that return auger and put it back on the return pan so we can dump it over the screens. And then our tailings auger also has a camera that we can monitor what that material looks like and make adjustments according to what it looks like as well. All right, well, we've been talking a little bit about the technology on this machine that allows you to maintain a acceptable grain quality and grain loss, right? So this machine has Combine Advisor. So what that system is going to do is it's going to allow the operator to set a target of what grain quality and loss is acceptable in the machine. So it's not going to automatically adjust to make the magic happen to achieve the perfect sample. The operator has to manually set the machine to an acceptable range that they like, and then they're going to activate that system. And that system is designed to maintain that set target. And it's going to look at the loss sensors. It's going to look at the grain images and the clean grain and the tailings. We also have active terrain adjust. So we have a chassis fore and aft tilt sensor because it's going to need to change the cleaning fan speed and the chaffer and sieve openings to adjust for roll and pitch, right? So that's going to affect the machine. So it's looking at that. Not all combines have active terrain adjust. We don't really use that a lot around here because it's a lot of flat ground, but the guys that are rolling up and down hills, that'd be pretty important to know that data so it can make changes according to what ground you're moving over to achieve the target performance value or whatever you want to call it for the operator. So this machine's not going to automatically adjust everything to achieve the optimal sample. The operator still needs to know how to set the machine, and then it's going to use all the inputs from the system to maintain your target. So And also you can optimize the performance. So if you look back through the window and you see a bunch of extra cobs and stuff in the tank, or a bunch of bean pods that you don't like, or whatever, you know, you can put inputs into the system and tell it, you know, you don't like the straw quality or the grain quality, or any. There's several different inputs the operator can put in to further optimize the system, and the combine will give recommendations on what you should change in order to get the results that you're wanting. So with optimized performance stuff, you can make changes, and the combine will give you recommendations if you're not satisfied with it, and then you're just constantly dialing in that target, and the machine's going to try to maintain that target. So we talked about a little bit about how the magic happens with the Combine Advisor. Didn't want to get too deep into that because the system's pretty complicated on how it works, and I'm mainly just showing you the path of the kernel, right? So, but I kind of had to explain a little bit about how those systems worked so you can fully understand the technology on this machine and how awesome it is, in order to get the corn from the ground to the truck, right? So now we know that the grain is going up the elevator. Let's go into the grain tank. All right, we're in the grain tank now. This is the top of the elevator, and here you can see the top of that clean grain elevator and that paddle chain. So it's throwing the grain into here, and right here you'll see a mass force sensor. So we are measuring the amount of grain that is entering the grain tank with this force sensor here, and this guy right here is very important to calibrate yield on the machine, so the operator knows in real time what the combine, what the crop is yielding at that point in time. And then down here we got a little gear case, and this auger right now is laid down, but whenever this auger is up, this little gear case is turning this loading auger here. So this fills up with grain in here, and then we're going to auger this corn into the tank. All right, so I've got the loading auger folded back up. So this grain tank has the power fold option. So this loading auger will fold down, and all these panels will fold down to where it's flat across at the top. I do have a side panel off right now. It had a little battle wound. It's at the body shop at the moment. Anywho, grain is coming out of this loading auger and coming down, creating a pile in the tank. Now here we have active yield force sensors here. And when the grain piles on top of it, it's calculating the force of the pile, and it's using that data load after load to help calibrate this force sensor in the tank in order to create a more accurate yield data, minimizing operator inputs. So that's what those little force sensors are right there on top of the cross auger covers. So underneath these covers are cross augers. So when the grain tank gets full and it's coming up and it's pushing these sensors, so that's 3/4 full, that's all the way full. Hey, we need to unload. Operator hits the unload button, and then these cross augers are going to kick on, and it's going to auger the corn or beans or whatever you're harvesting into the charge housing of the vertical. So it's taking all the material that way. So it's pretty amazing, the path of the kernel, right? Comes into the machine, goes through the rotor, drops down, goes to the right hand side of the machine, comes up this elevator, up this tube, down into the bottom of the grain tank, augers out to the left hand side, goes into the charge housing, goes up through the vertical auger, and then out into the horizontal augers and into your grain cart, right? Pretty amazing. So here is the charge housing on here that I was talking about. So the grain, these sprockets here, I'm doing a little operation on this unit here. I did put a vertical in it and got some issues with the sprockets, but anyway, these sprockets are all turning, and then that moves the corn or grain into this charge housing, and then that vertical auger, which you guys have seen me take in and out, is taking it up into the turret and out the unloading auger tube. All right, so here's the combine visor I was talking about. You can see we got 3 different options to turn on and off. We got Harvest Smart. I didn't talk about that yet, but what Harvest Smart does is it will speed up and slow down the combine according to what is coming into the machine. So when you get into some low yielding crops, it'll speed up. When you start getting into some high yielding crops, it'll slow down. It uses inputs from, the rotor pressure sensor, how much pressure we got on that belt to maintain that speed, our mass flow sensor, stuff like that. It's going to allow that to happen. Now, you can only do this with a Pro Drive machine, so you got to have that Pro Drive with the 2-speed automatic transmission to actually run Harvest Smart. And we've had this technology since I think the 70 series, maybe 60. I'm not exactly sure on that, but I know the 70 series we did have that technology in there, and it's kind of progressed over time, but not a lot of people use that. It's not a feature people really rely on. A lot of guys just, like moving the stick back and forth. So, but it is there. And that's that active terrain adjustment I was talking about, where we're looking at the chassis tilt of the machine. Don't really need that on level ground where we're at, but the guys are in the hills and stuff might use that. And then here's that auto maintain I was talking about, that is going to allow the machine to automatically adjust threshing clearance, rotor speed, cleaning fan speed, chaffer, and sieve adjustments here. Right, that's what the auto maintain is going to do. And then here, as I was talking about, we can set our performance target. So once we get the machine to where we like it, we could set that performance target, and then the auto maintain will take over. And this is just our automation status, whether our Harvest Smart, active terrain adjustment, or auto maintain is on or off. And here I was talking about the optimized performance. So we have a list of performance issues that we could have, and then we could go in and say we got heavy shoe loss, we can pick on that. And here is where the combine will bring up reported issues that it's seeing as well, that it might make recommendations on changes. So let's go back to our main combine screen. Here you'll see the live camera. So when we got grain moving through there, we can see the clean grain, the tailings, or we can monitor both of them at the same time. So some guys will watch this as they're going through the field and actually see what the pictures are looking like inside of there. All right, so here's our main page where we can control the combine here. So we can go to a preset setting, whether it's dry or wet, or threshing conditions or cob conditions, and then we can enter that in and hit OK, and then it'll go in and start changing all these things. So if the machine was running, we'd be showing threshing speed and cleaning fan speed, but we don't have it running here in the shop. But this is where we change that threshing clearance, how close the concave is to the threshing elements. This is how we change our rotor speed here, our cleaning fan speed, our chaffer clearance, and our sieve clearance. And that is the path of the kernel. All right, well, that's the path of the kernel. I hope you guys enjoyed that. That's a lesson that I give to every entry-level technician that's wanting to learn combines. First we got to understand the path of the kernel. Then the next step is we got to learn how all those systems drive. We got to go into the drive systems and know how the power flow works on the machine. How does the feeder house turn, the feed accelerator, the rotor, the cleaning fan, the cleaning shoe, the chopper? How do all those things run? How does the power flow work? What happens when you turn the separator switch on, the feeder house switch on? So that would be the next step I would go into, is to go over the drives. And maybe that's something I'll do on the next video on the path of the kernel, is we'll go into the drives of the machine and kind of explain the power flow and how it all works. But today, we touched on how all the systems are working together to get the corn from the plant to the truck. So now I'm going to show you guys this cool new tool that I talked about in the beginning of the video. So let's check this out. Today I'm going to show you a cool new tool that I got, and I think it's going to save a lot of time for me out in the field pumping coolant or high guard back in. And I recently bought a Milwaukee transfer pump. Now what really sold me on this, I mean, Milwaukee says that it's only meant for water, but they put a nitrile rubber coated impeller in it, so it can handle a bunch of different products like oil, fuel, coolant, stuff like that. So I went ahead and bought it. Let's give this thing a try. All right, there she is. I got some clear hose and put some garden hose adapters. This is 5/8 clear hose because I wanted to, see it go through the hose and everything, and this hose is pretty flexible. So I had to drain the coolant out of this giant 9RX 640 wide track model. She's got plenty of room to, get a ladder in there and work on the engine. I really like these wide units here. This tractor is pretty new. Anyway, I had to put a turbo on it. Long story there, really can't get into it. But anyway, I just wanted to show you, this Milwaukee transfer pump. So I had to drain the coolant to replace the turbo. Got the hose up there into the aeration tank, and we're going to pump this coolant back in. So you got a cap here, put a 6.0 battery in it, and yeah, let's give this a shot. Oh my, that was instant. That primed really fast. Now this is the first time I have used this. So there was about 20 so gallon of coolant in here. Boy, it's really sucking her down. I'll make sure I don't overflow that tank. Wow, it's really sucking her down fast. Now another upgrade I want to do is I want to get a suction screen for the bottom of that. Now this coolant's really clean, but in the summertime you'll get flies and gnats and stuff that get on top of there, and I want to kind of eliminate that. Uh-oh, better shut her down. It's getting a little full up there. Let her go down a little bit. Man, that thing pumps fast. My goodness. Yeah, let's go a little more. Better check. Oh, yeah, it's getting full. Let that calm down a little bit. It's settling. I think we can handle the rest. Good enough. Holy smokes. That was quick. Well, I think that's the fastest I've ever put coolant back into a machine. I mean, holy crap, it sucked that thing down like it was nothing. ZK Master Tech approved.